Everything around us is made of chemicals. These chemicals are not static. They constantly interact and change. This interaction and transformation of chemicals are called chemical reactions. Chemical reactions are a fundamental part of our world. They are the reason why we can breathe, cook food, or even see. Understanding chemical reactions is essential for grasping the world around us. From the smallest processes within our bodies to the largest industrial processes, chemical reactions play a crucial role. By studying them, we learn how matter interacts and changes, giving us the ability to control and manipulate these reactions for our benefit. Imagine striking a matchstick. The heat from the friction initiates a chemical reaction between the chemicals in the match head and the oxygen in the air. This reaction produces light, heat, and new substances, visible as smoke and ash. This simple example illustrates the transformative power of chemical reactions. Chemical reactions can be represented in a concise and standardized way using chemical equations. A chemical equation is like a shorthand notation for chemists, allowing them to communicate complex reactions easily. In a chemical equation, the substances that undergo change are called reactants, and the new substances formed are called products. Reactants are written on the left-hand side of the equation, while products are written on the right-hand side, separated by an arrow that indicates the direction of the reaction. For example, the reaction between hydrogen and oxygen to form water can be represented by the following chemical equation. 2H2 plus O2 gives 2H2O. In this equation, hydrogen, H2, and oxygen, O2, are the reactants, and water, H2O, is the product. The numbers in front of the chemical formulas are called coefficients, which balance the equation. A fundamental law in chemistry is the law of conservation of mass, which states that matter cannot be created or destroyed in a chemical reaction. It can only be transformed from one form to another. This means that the total mass of the reactants must equal the total mass of the products. To reflect this law in chemical equations, we balance them. Balancing a chemical equation involves adjusting the coefficients in front of each chemical formula so that the number of atoms of each element is the same on both sides of the equation. For example, in the balanced equation for the formation of water, 2H2 plus O2 gives 2H2O. There are 4 hydrogen atoms and 2 oxygen atoms on both sides of the equation. This balancing ensures that the equation accurately represents the conservation of mass during the reaction. Chemical reactions are the foundation of chemistry and are essential to understanding the world around us. They are involved in everything from the air we breathe to the food we eat and the medicines we take. By studying chemical reactions, we gain a deeper understanding of how matter interacts and changes. Chemical equations provide a concise and standardized way to represent these reactions, allowing chemists to communicate and study them effectively. Balancing these equations is crucial for ensuring that they accurately reflect the law of conservation of mass. Mastering the concepts of chemical reactions and equations is not just about passing exams. It is about understanding the fundamental principles that govern our world. As you progress in your study of chemistry, you will find that these concepts are essential for comprehending more complex topics and appreciating the intricate beauty of the chemical world.